Good morning. Welcome to Rules of Exponent, Chapter 7. In this section, in this video, we're going to look at remember, because you've already learned this, the rules of exponents that you've learned in previous classes. So, what we're going to do is use rules of exponents to simplify algebraic expressions. Now, these notes, you have these notes, so please note them as we go along. When you're adding and subtracting monomials, you combine like terms. Remember, like terms have the same variable and exponents. So, for instance, x squared plus x squared, those are like terms because they both have x's and they have the same exponent. However, x cubed plus x squared is not a like term, and we can't combine them. We can multiply anything, but we can't add these together because they're not like terms. So like terms have the same variable and exponent. And of course, x plus y are not like terms because they do not have the same variable. So it has to have the same variable and the same exponent. If that's the case, then we just combine, add or subtract the coefficients. We do not add or subtract the exponents. So for instance, in the case that we had below, x squared plus x squared, remember the coefficient of each of those are 1, so that would be 2x squared. Now this is the example that's in your notes. So for this example, we notice that this is a like term. They both have x squares and they both have a y. So therefore they're like terms, and we just combine the coefficients. So we look at 9 minus 10, which is -1. And then the exponents, we do not add those exponents. The exponents stay the same. We could also write this as -x squared y. Both of those would be acceptable. This is sort of a word problem. Subtract 6w from 8w. These are like terms because they both have w. And when we subtract from, remember the wording subtract from means that we have to reverse the order. So it's 8w minus 6w, which is 2w. Okay? And again, those are the notes. You need to write these down in your notes. The second rule is the product rule. Product, remember, means multiply. So here we're multiplying monomials. So we want to remember, you can multiply anything. They do not have to be like terms. So we want to multiply the coefficients and add the exponents when we multiply. So in your notes, in that second column in your notes where it has x to the a times x to the b, you want to write that as x to the a plus b because you add the exponents. Okay? So remember, when we multiply coefficients. So remember the coefficients here are 1 and 1. So 1 times 1 is simply 1. And then we add the exponent. So this would be h to the 2 plus 6. And of course, we wouldn't write it like that. We could write it as h to the 8th. Again, we multiply the coefficients. So -2 times 7. And again, this is in your notes. Make sure you're writing this in your notes. Is -14. Then a squared times a cubed gives us a to the 5th. We have to remember that there's an understood 1 as the exponent here, so that becomes b squared. And that's our final answer. So remember, you want to multiply the coefficients and add the exponents. Rule 3 is the power rule. Power rule is when we raise a power to a power. We always treat coefficients the way we always have. So we're going to raise the coefficients to the appropriate power, but now we're going to multiply the exponent. So in that second column in your notes where it has x to the a to the b, we're going to write that as x to the a times b. Okay? Excuse me. So for this one, we have x squared raised to the 3rd, so we multiply those exponents. And the reason we do that, because that's like saying x squared times x squared times x squared. And again, we add exponents, so that's x to the 6th. So we can just multiply those coefficients. For this problem, we need to remember the order of operations. So that means that we have to do what's in the parenthesis first. So I can rewrite this as negative 2 squared m to the 5th squared times m to the 3rd. So negative 2 times negative 2 is positive 4. M to the 5th, we're going to multiply these exponents, so that gives us m to the 10th, and then times m to the 3rd. Now, because we're multiplying, we're going to add those exponents and get m to the 13th. That is the power rule. Next is the quotient rule. The quotient rule is when we divide monomials. So again, we always treat coefficients the way we have since the beginning. So we're going to divide the coefficients and we're going to subtract the exponents. So x to the a over x to the b is saying x to the a minus b. You want to write that in your notes. So now, here's an example. So we treat coefficients the way we always have. So we're not subtracting those coefficients. We're dividing 27 over 42 times x to the 5th over x. Now, you can use your calculator to do this. You can do 27 divided by 42 on your calculator and then math fraction. And then if you did that, let me do that for a second because I don't feel like doing it in my head. We get 27 divided by 42 math fraction on the calculator, which gives us 9 over 14. Now, we did not subtract that. We divided. So this becomes 9 over 14, and then we're going to subtract the exponents. So 5 minus 1 is x to the 4th. Okay? For this one, we have to do power to a power first. So we get y to the 4th over y to the 4th. And when we subtract this, we get y to the 0, which brings us to a rule which we're going to talk about later, is 1. But we still subtracted those exponents, so this is 4 minus 4, which is 0. Okay? Now we're coming to the negative exponent rule. Now remember, these rules only apply to exponents. They do not apply to coefficients. So negative coefficients remain the same. They don't change. If a negative exponent is in the top, we're going to move it to the bottom and make it positive. For instance, we have x to the negative a, which is in your notes, and we're going to write that as 1 over x to the a. If the negative exponent is in the bottom, so if we have 1 over x to the negative a, then we move it to the top and it becomes positive. Okay? All right, so here's an example. These examples are in your notes. So remember, we're going to look just at this part. The negative 5 stays the same because it's a coefficient. That doesn't change. But the x to the negative 2 now goes to the bottom. And that's our final answer. In this case, we treat exponents we treat coefficient the way we always have. So 4 divided by 8 is 1/2. K squared divided by k to the 5th gives us k to the 2 minus 5, which in turn gives us 1/2 k to the negative 3. 2 minus 5 is negative 3. We're going to write that at the bottom because it's negative. And that would be our final answer. So negative exponents move. If they're positive, they move to the bottom. If they're at the bottom, then they move to the top. This last rule is not in your notes, but I would write it at the bottom of your sheet, and it's the 0 exponent rule. We talked about that for a second ago. Anything raised to the 0 power is 1. So x to the 0 is 1. Anything raised to the 0 power, it doesn't matter what it is. I can raise 2,375. If I raise that to the 0 power, it's 1. Doesn't matter what it is. Anything raised to the 0 power is 1. So you want to write these examples down. 3x to the 0, this becomes 1. So now I have negative 3 times 1 times y squared, which of course I can just write as 3y squared, negative 3y squared. Now, the reason I only raised this to the 0 because it was not in parentheses, so this 0 only applied to the x. However, in this case, since it's in parentheses, since we have parentheses around here, the 0 applies to everything, so the answer to that is simply 1. Okay? So, you go to the next page in your packet. We're going to do some examples. And I would love for you to pause the video and try it and then come back and then check your answers. Okay? So I think that would be a good thing to do to see how well you do. We're going to start with the first column on your paper. So do the first column, pause the video, do the first column, and then come back and check your answers. Okay? Welcome back. So now this first case, these are like terms, and we're subtracting. They're like terms because they both have a cubed and they both have b squared. So to subtract this, 3 minus 5 is negative 2. And remember, the exponents stay the same when we add and subtract. So this is combining like terms. That was the rule that we used. Okay? In this rule, we're going to use the product rule because we're multiplying. And the product rule says that if we have the same base and we multiply, we can add the exponent. So this becomes a to the 4th plus 3, which is a to the 7th. Now, of course, you don't need to write this step. You can go straight to this step. Again, this is the product rule. When multiplying, remember to multiply coefficients first. So negative 3 times negative 5 is positive 15. And then we add the exponent. So 3 plus, is that a 3? 3 plus 4 is 7. That's a 2, then it's 6, but I think that's a 3. Then for problem 10, we're raising a power to a power. So this is our power rule. And remember, in the power rule, we treat coefficients the way we have since the beginning. So this becomes negative 4 squared, y to the 4th squared. Negative 4 squared is positive 16, and then y to the 4th squared is y to the 8th because we're going to multiply those exponents. This is negative 4 times negative 4, and this is y to the 4th squared, which means I multiply the exponent. Again, okay, we have the power rule, but we also have negative exponents rule. So we can treat this, we can do this two different ways. I'm going to start by doing 4a to the negative 3. Now, well, actually what I'm going to do is I'm going to rewrite this as 1 over 4a cubed times 1 over a to the 4th. Okay? Because it was in the numerator, I moved it to the denominator and it became positive. Then I have to look at this as 1/4 cubed times a cubed times 1 over a to the 4th. So 1 over 4 cubed, or 4 cubed, you can do this on your calculator. That's 4 times 4 times 4 is 64. So it's going to be 1 over 64. And then I'm going to add these exponents and get a to the 7th. Okay? This is the quotient rule. And remember, in the quotient rule, we treat coefficients the way we have since the beginning of the time. So this becomes 3d, and 8 minus 10 is negative 2. But I can't leave it like that. I always want to write it with positive exponents. So I'm going to write this as 3. The 3 stays in the numerator because it doesn't have a negative exponent. And then this becomes d squared in the bottom. Okay? For this one, we have to use the power rule first. So this becomes 2 to the 4th, y to the 5th, raised to the 4th power, over 10 y to the 15th. Now, 2 to the 4th is 2 times 2 times 2 times 2, which is 16, I think. Y to the 5th to the 4th, we multiply those exponents, we get y to the 20th over 10 y to the 15th. We're simplifying 10 over 16. 2 goes into both of those, so that gives me 8/5. And then I subtract exponents, so that's going to give me y to the 20 minus 15. So this is 8/5 y to the 5th. It's my final answer. Okay? So what I would like for you to do is I would like for you to finish this worksheet. When you finish, raise your hand, and I will come and check it for completeness. And then once you're done with that, there's an online assessment that you must complete by the end of the day. So if and I think the online assessment is like 20 questions. So if it starts to get late, you might want to do that online assessment and finish this worksheet for homework. Have a great day.